So now we're going to talk about partial sums. So the nth partial sum of a sequence is basically the sum of the first n terms, a1 plus a2 plus a3 all the way up to an. Using summation notation, this can be represented with this large uppercase Greek sigma representing summation. That is an operator. It's like a bunch of plus signs combined into one. It just means add up everything. And here's how they tell you what it is that you need to add. They have this variable called I, which is the index. And the index is just a counting variable. It starts at 1, which is the first element in the domain of the sequence, and it goes all the way up to n. So we're only adding up the first n terms of the sequence from I equals 1 to I equals n, and what we're adding up is all the ai's. So first I starts with 1. That's the lower summation, or the lower limit of the summation. So you plug in 1 first. Then you let I equal 2 and you add a 2. Then you let I equals 3 and you add a 3. And this tells you where to stop. You keep going until you've added the last one, which is an. So I is the index of the summation, n is the upper limit, and 1 is the lower limit. And here's an example. So I is the index, the lower limit is 1, so we're going to start adding with a1, and we don't stop adding until we get to a5. That's what all that means. So a1 plus a2 plus a3 plus a4 plus a5. And here's what each one of those looks like. Well, when I is equal to 1, a1 is equal to 1 squared minus 2, plus when I is equal to 2, a2 is 2 squared minus 2, plus when I is equal to 3, a3 is 3 squared minus 2. When I is equal to 4, it's 4 squared minus 2. When I is equal to 5, it's 5 squared minus 2. So that's what that symbol represents, that sum right there. So let's go through and find out what it equals. So let me see. That's 1 squared is 1 minus 2 is negative 1. 2 squared is 4 minus 2 is just 2. 3 squared is 9 minus 2 is 7. 4 squared is 16 minus 2 is 14. And 5 squared is 25 minus 2 is 23. And then we add all these up. When you add them all up, you just get 45. And that is the fifth partial sum of that sequence. Adding up the first 5 terms, we end up with 45. Now here's something taking us back in the other direction. With this one, they give us the sum of all the terms, and they ask us to use summation notation to represent that sum. Well, this is obviously a1, the first term. This is a2, this is a3, this is a4. Of course, after that would be a5, a6, a7, a8. And this one right here, we have no clue how many terms we have to look at before we get to 31. But there's a way of figuring it out. If you notice, the difference between a1 and a2, if you subtract 7 and 5, that difference is equal to 2. Also, the difference between 9 and 7 is also 2. And also the difference between 11 and 9 is also 2. So if you take two consecutive terms and subtract the bigger one minus the smaller one, the result is always 2. So if you continued in this fashion, you could see what the other terms were. So for instance, after 11, a5 then would be equal to 13. a6 would be equal to 15. a7 would be equal to 18. a8 would be equal to 21. a9 would be equal to 23. a10 would be equal to 25. And we're almost there. a11 is 28. And that means that, let's see, 13, 15. Ooh, I started counting by too many. I'm sorry. Those are wrong after that. We're only going by twos each time. I was going by threes. So yeah, we're only going by twos. My fault. So that's a 5. A 6 is 15. A 7 is actually 17. A 8 is actually 19. A 9 is actually 21. A 10 is actually 23. A 11 is actually 25. A 12 is actually 28. I mean 27. See, I keep trying to go by threes. 27. A 13 is equal to 29. And finally, A 14 is equal to 31. So basically, they're asking me for that summation there in summation notation. Well, that would be the sum, and the index, we started at 1. So we started with a 1, which was 5. So I equals 1. And we all went all the way up to 14. So we didn't stop until we got the 14th term. And then we have to describe the individual terms. Well, let me see. If I start with 5, what I'm doing is I'm adding 2 each time. But the first one, when I is equal to 1, I actually get 5 itself. So I can't just multiply n times 2, because then the first term would be 7 actually. So it's going to be n minus 1 times 2. This is what I'm going to get for an. So an is 5 times n minus 1, or 5 plus n minus 1 times 2. So that's 5 plus n minus 1 times 2. You can check it out. Let me put the 2 in the front. You can check it out if you want to and plug in all the values and make sure you get the individual terms that you're supposed to get. But this is the summation then. From I equals 1 to 14, you can distribute the 2 to get 5 plus 2n minus 2. Or finally, the summation from I equals 1 to 14 of 2n plus 3. This would be that sum using summation notation.